Hello and welcome to this third video in our kind of snaky series where we're getting this guy to move around in 3 dimensions oh, he's circling me. That's unexpected behavior. In the classic Snake Arcade style or Nokia phone style of movement. Now, last video, he was exhibiting that kind of behavior where he's moving back through his body, which is a bug. It shouldn't be able to do that. So in this video, we want to correct that. And I think I've just spotted another bug. Is he ever moving in a negative Z direction? So there might be something wrong with our algorithm. I say our to spread the blame. Right, so let's go and sort him out. And I think we need a new plan. So I think I've got an idea of how we can do this. So let's bring up our plan and let's add a layer, layers, add new layer, and then spreader. Should we just go pink this time? We'll go pink. That's just filled it. That hasn't filled it. How do you fill style? Fill the shape. There we go, right. And I'll draw it. Oh, control Z. Oh. Right, fill style, it's ready. Okay. Now I want to select that. Now I want to deselect everything. Can I do, is that, okay. We've got the correct color for our canvas. Right, now we want our new snake rotation algorithm. Okay, I think we should base this on a dice this time, because the reason why our snake was moving back through its body was, let's just say, if it had chosen this direction, and I think we called that direction 2. Let's just have a look. Yeah, so, oh no, that was direction 3. So 1 would be, which direction? 1 would be moving forward, 2 left, 3 right, 4 up, 5 down. So, if we had chosen to move in direction 3, our next choice, after our snake moves 10 steps, remember, our next choice might be to move 2 in direction 2, which is perfectly allowed according to our system. Our system, the only thing we had disallowed was to move backwards in space, which is negative Z. So one, that kind of explains what's going on in terms of the snake not being able to move in any direction. It wasn't moving negative Z. But also it now explains why we've got incorrect movement back through the body. We're not rotating the snake. After, let's say, we've... Oh, no. Does Control Z just delete the whole layer? No. Okay, right. After we've moved our snake, we need to actually rotate it so that it has a new forward direction. So that 2 would be over here. 3 would be this way, and this would continue to be 1. This would be our forward direction, which previously was this one. So basically we need to rotate our snake. But dealing with like perpendicular rotations like this using quaternions in Unity can be a bit tricky. So I've got an idea. Let's although I found it tricky to draw squares on my screen here. Right. So my idea is we have our cube as usual, and we base this on dice faces. So on a dice, the opposing numbers, as you know, have to add up to 7. They have to add up to 7. So the opposing side would be 6 here. If this was 3, the bottom would be 4. And if this was 5, over here would be 2. Okay, so if we've done that, that means that we could, at the start of our which direction, we could have a random number between 1 and 7, including 1. So we could randomize that. So at the moment, we've got between 1 and 6, because we could only move in one of those 5 directions. Beforehand, we were saying you can only go forwards, left, right, up or down, and not backwards. But this system's kind of causing us some problems. So the only good solution I can see, or obvious solution, is to do this. So we don't want to do that. We want to choose one of these 6 directions, and then have our head segment rotate by Euler angles in one of these 7. But what we also need to do is record what was the old direction. And what we'll say, if that adds up to 7, then recompute a random number. So go and get another one, because if it adds up to 7, that means it's rotated 180 degrees and it's just going to go back through its body. So that's the idea of the new algorithm. Let's go and do that. Let's try and do that. And I'm going to keep this video a lot shorter than the last video, which was about an hour. Okay, so so we need to go into, also, while we're here, let's make, oh yeah, you noticed the snake was moving a lot faster. In the last video, it was moving every second, and I've just increased that by a factor of 10, so it's going 10 times as fast. Right, so we can see its movement a little bit easier. Okay, right, so, you know what I've just thought of? In the snake's movement, we only want to be going forward because we're rotating the snake now. So its forward direction will change. So we only need one of these. So we can, I'm not going to delete them, I'm going to comment them out just in case I'm wrong. So let's comment all of those out. We don't need to make a decision. We just want to move the snake forward, and we don't need this one. Missed that one out. So all we're doing in movement is moving the tail segment, which is held by the which segment variable or index in the array. We're moving that to the head of the snake. We're then moving that forward, the new head of the snake forward, and then down at the bottom, remember, we just make sure that the head segment is now the segment we've just moved. There we go. And we say the tail segment is the previous segment in the array. And then we increase a step because we've moved our snake 1 step. Okay, so we've taken care of the movement. So here's check direction. So the first thing we needed to do was record the previous direction. So we'll say the old direction equals which direction. That's easy enough. Okay. And what we're doing here, we're prevent the snake from moving back through its own body. That's what we're going to do. So then we're going to say while old d plus which d equals exactly 7, keep going to find a new direction. And remember, we want that range 1 to 7, so it can go forward, back, left, right, up, down. Okay. Now we need to rotate our snake. So rotate the snake. Catchy. Rotate the snake. Rotate the snake. And rotations are a nightmare. Okay, so we want to say something like segments, which direction? Which segment. So that gives us, if you remember, the tail segment in our snake. We want to get hold of its rotation. No, we don't. We just want to get its transform. And then we want to say set axis. No. Or do we? No, we do have to get hold of its rotation. and we want, yes, Euler angles to equal, this will depend on which axis. So we want to say something like, if it were going, you know what, I'm going to refer to my old layer. We'll now change this to say that this direction, I'm not writing on the correct layer here. Okay, now I am. We'll say this direction is newly called direction 6. So it's back along the Z. Okay, so I can remember these. Right. So we'll say if the direction is 1, then we want to go new vector 3. That's just going to be positive 1 in the Z direction. So 0, 0, or 90 in the Z direction, I should say. Is that right? Yes, we want to go by 90 degrees. Euler angles is a way, in Unity by the way, that we can set rotations by a vector instead of having to deal with quaternions. Unity actually uses quaternions, which is a way of moving things using the 4th dimension in 3-dimensional space to get smooth rotation, which I don't understand, so I'm going to keep this to Euler angles. Right, so we need to decide which direction we're. Let's use a switch case this time. If you haven't seen one of these, or don't use them, they can be handy. So what you do is you write switch, and then we're thinking about, we're looking at this variable. So depending on this variable, which can be 1 to 6, we're going to have different cases. So case 1, if which direction equals 1, and do that, and then break. Okay, and then I want to do that another 6 times. 2, 3, 4, 5, and 6. There we go. 6, 5, 4, 3. And so this is a bit tidier than what we did last time in the movement direction when we did all of this if else, I don't know. Switch case is a little tidier here. Okay, so direction 2 is moving left, so that's rotating negative 90 on the y-axis. I've just seen a mistake. I'm not rotating by the z-axis. The z-axis would be like this. If you're going forwards, it's still the y-axis. But you're going 0. It's basically 0, 0, 0, 0. It's just the identity, meaning no rotation. Okay. Case 3, that's turning right. So that wants to be plus 90 on the y-axis, so it's like that. 4 is going up, so it wants to be the right axis or the x-axis by minus 90. So minus 90. I'm just going to remove the 90s from here in case I forget those. Right, 5, we're going down. So that's x-axis plus 90, I think. And then 6 was going back. So that's minus 180, or just 180 on the y-axis. Okay. I think that's it. Well, we're in a position to test now. So what do? We've made sure that the direction cannot be back on itself by using our dice algorithm, which I invented, probably invented before. Then we're rotating that tail segment, which is a segment that's going to be moved to the head, so it's the important segment, by 90 degrees according to our excellent picture. Then in our move snake, we're only moving it forward. So let's go and see what on earth our snake will do after all of that. And we've got an error. What have we got? Which segment transform rotation equals new? I'm sure I could change all of those. Do I just need to... Was I right to begin with? Let's just see if that's fine. Oh, it's taken us back to the first one. Oh, maybe I'm doing this completely wrong. Do I need to say vector 3 transform equals? Or there, do I write Euler angles? Sorry about this silence, here we go. No, I don't know. I should be able to change all of those at once. I don't know what's going on there. Right. I don't have confidence in what I just did. I still don't have confidence. Okay, so our snake is moving forward. Our new direction, by the way, is 1. So there's something wrong with our random direction function. It is moving in the correct direction according to its randomized number, but we're just producing a new direction of 1 every single time. Old direction equals which direction? Yeah. While old direction plus which direction equals 7, go and get another direction. That's fine. How can it always equal 1? Switch, case 1, case 2. I have no idea what's going on here. What's going on? Oh, I need to, I've just realised, I need to firstly choose a new direction. Okay, there we go. So beforehand, of course, they wouldn't equal 7. It's if because the first direction is 1. So it always equal 2, so it wouldn't go and get it wouldn't go and get a new random number yet. Okay, so this time this time we at least get a new direction. So we didn't even have an opportunity to see if our snake was, after that fact, moving in the right direction. Let's have a look. Okay, so it's definitely not definitely not working. It's concertinaing up, and it's just moving along the z-axis. So okay, so 2 places. One place is in this check direction. So something in here could be wrong. although I'm intrigued that it's just moving according to one direction. So I think it might be in move snake, and I think we just want to refer to vector 3 forward. Because if you use vector 3 forward in a translate of a particular object, that vector 3 forward will refer to the direction that the game object is facing. So let's just see if that corrects things. Although there must be another problem, because the snake was concertinaing up, so it does suggest that in some sense it was moving back through its body. Something's working here. It's definitely changing direction, which is good. We've got some progress. It looks like a sick snake, or like a snake that's got a virus. Oh, I think I know what's happening. We need to make sure we then, after we've rotated the head or the tail segment that's being moved, we need to make sure all the other segments are facing that direction. It was definitely moving back along the z-axis, which is another gain. Okay, so final change we need to make. So after we've rotated our snake, I'll just put this debug log back up where it belongs. So after we've got this, after we've got our newly rotated tail segment, we can say for int I equals 0, while I is less than the length of our snake, which is this array's length, increment I by 1 each for loop, and we want to say for every segment its rotation equals the rotation that we've just corrected for the which segment. We don't have to change again the which segment zone one, but we'll leave that in there. So this loop will look at this segment as well and change it to itself, which is not optimal, but you could tidy that up on another occasion. Okay. So how long have I been? Maybe 20 minutes? Okay, it's moving up. And back through its body. No. I haven't seen it move back through its body in any other direction. It was when it's going up and then it can go down. Okay, there might be something wrong just in my logic, not in the code, if that kind of makes sense. So let's have a look. So 6 and 1 should be opposite. And I've got minus 90, and I've got 0 and 180. So that's fine. Actually, it was just the x-axis, so it's something here. 4 and 5. Minus 90, 90. Oh! 4 and 5 don't add up to 7, do they? So I've got to... Right, so 1 and 6 should be opposites. 3 and 4 need to be opposites. Okay, so let's make this one minus 90. Of course, my old diagram didn't correspond to the dice. I needed to change that. Right. 5 and 2 have got to be opposites. So we'll make this minus 90. Okay, let's just... I think that's okay. So 1 and 6 are now opposites. 1, we're just at identity rotation. So we're just flipping ourselves, we're reversing ourselves on the z-axis or according to the y-axis. So 2 and 5 should be opposites. So 2 is now going up, 5 is going down, and 3 and 4 should be opposites. 3 is going right, and 4 is going left. Okay, so let's see. Also, while we're here, let's just, to make this video more interesting in terms of changes, so it's not just a bug, in move direction, every time we move, let's make the head have a new color. So we could say segments, head segment, get component, and we want to get hold of the mesh renderer, and then we can get hold of its color. Can I get hold of the color from there? Let's go onto a new line. No, material, that's what I need. Material, and then its color equals, I think there's a random HSV, yes. And I'll just bang that in there. Right, so we might get a colourful snake to celebrate. Let's have a look. As long as it doesn't, so we're after it not moving back through its own body. That's the idea. And then, maybe speaking too soon, okay, the colour's working, looking a bit better. Then we've got our snake with all correct movement. So we're ready to do some really truly interesting things, like creating hundreds of snakes and getting them to chase each other. Okay, our snake is now moving beautifully. It's not moving back for its body. That's fantastic, and it's nice and colourful. Right, thank you very much. See you in the next video. Goodbye, snake.